Okay, so we want to use the both hazards, data hazards exist. We want to use the most recent data, and we need to revise the MEM hazard condition. Okay, so we have already seen the conditions here. These are the conditions. So we need to decide the update the MEM hazard condition so that we will see where to forward the data from. So these are the conditions for the MEM hazard. Again, we check reg write, whether register is not equivalent to destination register is not equal to x0, and then we will forward the data from the MEM write back register. Okay, so let's try gradually writing these values. And again, it is a little bit complicated to understand, so that's why animatedly I'll be going in a gradual manner. So first look at the code here. So it says that this instruction has reached to mem write back phase, this instruction is reached to xmem phase, and this instruction is reached to idx phase. Okay, so when there is a data dependency, we normally do, if it wouldn't be x1 here, we would normally forward the data from mem write back to this instruction, right? And if we were talking about the second instruction, the data will be forwarded from the xmem pipeline register. So this is the normal condition. We check for the reg write if it is set, if the instruction is writing into register, which is true. Okay, the instruction is writing into the register, which is x1. The destination register is not equal to 0. This condition also satisfy. And then look at the third condition, which is mem write back, which is the mem write back rd x1 is equivalent to rdx register rs1 x1. Okay, so we simply do forward the data from the mem write back phase. Okay, but here is a special scenario, which is a double data hazard. So in order to check this, what we need to do, what we should be checking, it's exactly similar to these conditions. So we are checking if the hazard exists in the xmem stage also. Okay, and what we do first is check whether this instruction is which is in the xmem stage is writing into the register, which is reg write signal. Again, we will check the reg write signal. If it is set to high, it means it is writing into register. It is not writing into the rd, destination register is not equal to 0. And then the third condition, if xmem register rd, which is this, is equivalent to idx register rs1, when this condition also satisfy, it means that it's a double data hazard. The hazard not only exists here, but also hazard also exists in between. So you can see when the instruction is writing into register, it's also not equivalent to x0, and this condition also satisfy, which means that the hazard exists, and what we are doing is we are converting it into not. So this is true, and this is true, and everything will be converted into false. When there is a false in between in the AND operation, everything will turn into false, and it will not be forwarding the data from the mem write back phase. Rather, it will be forwarding data from the xmem register. Okay? Do you follow? Yep.
I get one of the condition at the end operation false means the whole thing is false, but can you say that the blue things,
So you understand this, right? So this is the original condition that we upgraded after discussing whether the signal is writing into register, or instruction is writing into register, or it is not writing into the x0. Okay. Now we need to determine whether there is also a data hazard in between this x phase. Hazard means like the updated value that we are supposed to be using, the updated value of x1, which is in the mem write back phase, but another instruction in between these two instructions, it is also writing into x1. Okay, so to determine this, we need to check the destination register sitting in the xmem stage, xmem pipeline stage. Okay, how do we check that? We first check whether this instruction is writing into register by checking its reg write signal. If it is 1, then it means that it is writing, and if it is not writing into x0, it will again, this condition also will satisfy in this case. And check xmem, the rd in this register, xmem register, is equivalent to either rs1 or rs2. So first we are checking rs1 here. Okay, so here according to this scenario, this condition also satisfy. So this is true, this is true, this is true, everything is true, and then we turn it into false by not operation. Why we are turning it into false? Because we do not want this condition to execute, this output to execute. So when one input is false in AND operation, it will turn the entire condition false. Agreed?
So forward A, what forward A will do?
Forward A, so if you remember this diagram, the forward A, so it will decide whether to take the data from this register file, or take the data from XMEM, or take the data from MEM write back phase. So here when the hazard exists here, both of them, both of the places, then look at this one. Forward A value 1 means the value is coming from the MEM write back phase. Okay, so for the time being, just assume that this is not x1. Okay, this is something else. Let's say it is x20. Okay, now check this condition. So MEM write back reg write signal is 1. Okay, MEM write back register is not writing into x0. This condition also satisfy. And check MEM write back register RD, which is equivalent to x1, is also equivalent to IDX register RS1 x1. Okay, since we have these conditions also, we need to verify these one also. So XMEM register is writing into something, into a register, assuming that this value is not 1, this is 20. Okay, and this condition will also satisfy. What about this condition? Will it satisfy? XMEM register RD, let me do it here for the time being. Let's say 7. Okay, this will be more helpful. So XMEM register RD, is it equivalent to RDX register RS1? It is not. So which means that this condition fails, which is false, right? And false, so it will make everything false inside these red braces. And when we pass it through the NOT gate, it will turn it into true. So this was true, this is now true, and this is true. The data must be forwarded from the MEM write back phase. Okay, understand?